recording and show you where we've been. Also to name and shame you as well, which is a lot of fun. So transforming graphs revisited. This was really well done by so many of you. But I can't take chances with grade 8. So Hamza, if you can take yourself off video, please. And also Crystal, just take yourself off video, please. Thank you. Right, thanks guys. So you will recognize that, and that, and that, and that one, and that one. You'll recognize that as well. I'll come on to that again. The reason you'll recognize it is because I spent a long time taking a screenshot of those Mimeo slides, cropping them, enlarging them a little bit, saving them as bitmaps because I had no choice in the matter, and uploading them to show my homework so that you won't have to sit here looking at the screen trying to copy it in just a few minutes and making a mess of your work and your lives in general. So you don't have to put it on show my homework. Either you print them off and stick them in on your lined paper, whatever you're working on, or you copy it out in freehand in your own hand with different colours, however you want to do it. I don't mind, but I gave it to you for a reason, not just to ignore it. That's the first thing I want to say. Here's the homework itself. I'm going to go large on this, put the grid on so we can all see what's going on. Boom. So when I say draw the original function so I can judge what that is, I've got to keep this little thing in my brain all the time, and my brain is not as fast as it used to be. I have a sort of lockdown brain, you know what I mean? I'm not at school being active, but I'm very active on the screen. So here's the original function, and we've got to do this to it. In other words, jump up 2 units. So for example, 1, 1 becomes 1, 3. That's 2 units. Or better still, translation of the original function using vector 0, 2. You're not going left or right, but 2 straight up. That's the first. I'm going over it. Okay, I'm not going to screenshot these because most of your work was brilliant, but this is being videoed, and when you get onto YouTube later tonight, tomorrow, whatever you want to do, just pause it and check your work. I've marked what I could as best that I can, and I enjoy marking your stuff because it's you. Here's the next one. Here's the original blue one, and I've got to go function of x minus 1, drop it down 1 unit. In other words, translate the original function, the blue one, using vector 0, minus 1. That drops it straight down. You can see this coordinate becomes that. That coordinate becomes that, and 0, 0 comes 0, minus 1. So you need to be accurate about this. It's grade 8, although examiners do mark your intention. That's what mark schemes say. They know what you're trying to do. But if you're too wildly accurate, they don't know whether you can't handle a pencil properly or whether you just don't know what you're doing, you're just having a wild guess. They won't give you the benefit of the doubt, but they will mark your intention. Here's the next one. Now watch this one, some of you, because you missed it. Here's the original function, and they want you to go function of x plus 2, f of x plus 2. And I showed you painstakingly when I introduced the lesson last time that function x plus 2 means go left 2 units, not go right 2 units. I told you several times this is counterintuitive. So this is a translation using the vector minus 2, 0. You're not going up and down, yeah? Just 2 to the left. Just get these 4 rules in your head. Next one. This is beautiful. This is the original blue function. And you've got to draw in y equals minus f of x, which you may recall is a reflection in the x-axis. At least one of you try to combine reflection and vector and translation. No, we're not sliding the blue graph anywhere. We're reflecting it. There is no up, down, left, right. It's just boom, reflect it in the x-axis. And that's all there is to it. This one. Yeah, it was quite difficult to mark your work. If I could see the blue one and then the reflection in the y-axis, I could see you got it right. I can't remember what the branches looked like. If you just drew me your little red tick, I thought it's obviously a reflection, but I can't be sure. So again, just show the original. Of course, in an exam, the original will be drawn for you, good to go. You just need to like do the transformation that they want you to do and get grade 8 in this topic. So this is a reflection in the y-axis, f of minus x. This one is beautiful. You've got to do y equals 1 minus f of x, or better still, y equals minus f of x plus 1. Now, the reason I prefer this rearrangement is because if you go minus f of x, it means reflect it in the x-axis first and then lift it up 1 unit. So originally, that blue thing would go down there. This blue thing would go down here. So I've got a V that looks a little bit like that. And then you just lift it up 1 unit. So first of all, reflection in the x-axis, followed by a translation using the vector 0, 1. So it's a double whammy. You need to do 2 things. Next one. Okay, so again, this is screenshots of the worksheet I gave you, which was a copy of something in the red book. It's a scan of a copy of a copy of a copy. See, and then I've got to enlarge it and it looks all not very clear. But when I came to mark your work, those of you who looked where I put the ticks, I looked at where this graph began and finished, and I tried to see where your graph began and finished. So a 0, 0 should become a 0, 2 because it's f of x plus 2, and a 4, 2 becomes a 4, 4. Because you can see I'm adding 4 units in that, 2 units in that direction. It's a translation using vector 0, 2. I don't know if they asked you for that, but this is a video, and I want it to be complete. And again, that is not a very beautifully hand-drawn thing. It's quite hard to use a graphics pen on a graphics tablet that's sliding around all over the place. But I would get my 2 marks for that, because my intention is definitely to start at 0, 2 and definitely to end on 4, 4. And my graph is sort of trying to follow this one as it goes across. I get my 2 marks for that in grade 8. So again, intention. Next one. Again, many of you have fallen down the trap. You saw a plus 2 and you shot off in this direction. No. F of x plus 2 means go left in the counterintuitive direction. So it's a translation using vector minus 2, 0. So my 0, 0 becomes minus 2, 0. That's like one of my key points. And my 4, 2, I think they want that to be 4, 2, has got to become 2, 2 if I go back 2 units. So that's that, right? Accuracy. Good starting position, good finishing position, and the curve tried to make it look half decent. But I would get my 2 marks for that because my intention is correct, especially as I've highlighted the coordinate where I'm finishing up on. This one's obvious where I'm starting from. This one, I need to teach you a holy word here. But let's do the basics first. Here is a function, I don't know what it is, but I know it ends in 4, 2, so the reflection here in the x-axis should end up on 4 minus 2. So I just extend the graph downwards with my straight line facility and just guess where minus 1 and minus 2 go. But look at that, that's meant to be like a reflection. So 4, 2 becomes 4 minus 2, a straight reflection in the x-axis, and of course all of you drew it brilliantly. Now I think it's an opportune time to teach you this holy word. 0, 0 is described as invariant. They've introduced it, it's brand new to this course, invariant. It was always around, but now it needed to be taught. It's invariant. Why? Because it does not change its position after the graph has been transformed. Now look at this. 4, 2 becomes 4 minus 2. 3 whatever becomes 3 minus whatever. 2 whatever becomes 2 minus whatever. But 0, 0, you reflect that on the x-axis, it's going to end up on 0, 0. That coordinate is invariant. That is a grade 9 word. They love to test this word somewhere towards the back of the exam booklet on the non-calculator paper. Yeah, I have seen 2-mark questions come up with this kind of thing, and they're testing the word invariant, and it's always in the context of transforming a graph or rotating a shape. Because if you rotate a shape and you rotate about one of the corners of the shape, the vertex of the shape, that vertex is invariant. That point, that coordinate is not going to change. But here in the graph, it's very straightforward, very easy to see. 0, 0, when you reflect in the x-axis, is 0, 0. It is an invariant coordinate. Right, that's grade 9. Next one, again a straight reflection in the x-axis, y equals minus g of x, straight reflection, that's 4 and a bit, so the reflection is going to be 4 minus a bit, that's like a quarter up to about 4, so I'm going to go a quarter down to minus 4, and again I'm being at pains to show where I'm finishing off, yeah? I get my 2 marks for that. Next one, y equals g of x, they want you to drop it down 2 units, so 4 becomes 2, and maybe a quarter becomes, if you take away 2, gives me minus 1 3/4. But anyway, I did it visually, so you can't put that on 4, 0, and then go down to 4 minus 2, because it's not actually 4, 0. If you draw it too sloppily, you won't get your marks, because you've not realised that this is slightly above 0, okay? So just drop it down 2 units, translation using vector 0 minus 2. Next one. Alright, so mine's terribly drawn, but I get 2 marks for this. I've got to go from g of x to g bracket x minus 2, and this means go that way 2 units, counterintuitive. Be very careful. Too many of you threw away good, easy marks because you saw the minus and turned left, or you saw the plus and turned right. That's naughty. You've got to look at my videos, look at my uploads of help sheets and stuff, and use it. Anyway, so a little bit 4 becomes 2 plus a little bit 4. So I sort of try to drift across 2 units to the right, and 4 becomes 6. In order to show it more convincingly, I extended the graph 5 and 6. So it's a translation using vector 2, 0. Or becomes the end. Yeah, this was hard to mark because too many of you just went bam, there you go, mark it. Well, I can't, because I want to be sure what I'm judging it against. So you should draw this out. Now, be careful. 0, 1, when you're going to transform it to h of x plus 1, must become 0, 2. 360 degrees 1 must become 360 degrees 2. I'm just adding 1 unit up in the air. Translation vector 0, 1. And 180 minus 1, if I jump up 1, that'll be 180, 0. So these points matter. So if you're doing this in the exam, plot a couple of coordinates and then try and follow the curvature of the original function. Okay, that's it. Just try and be accurate. Next one. Oh, I did this super large. Again, I remember marking many of yours that look like that, but I needed to see the original. So this was h of x minus 90. Remember, if it's minus 90, you go that way to the right. So 0, 1 becomes 91. That's a good point. 361 becomes 451 because that's 90 degrees across a bit more. And 180 plus 90 is 270. So 180 minus 1 becomes 270 minus 1. So I just plotted 3 points and tried to skillfully simulate the same graph and make it look like it's moving that way, 2 units. Translation using vector, sorry, not 2 units, 90 units. Translation using vector 90, 0. Okay, it matters. Again, you all understood it was a reflection in the x-axis. But have you noticed this cosine curve peaks at 1 and troughs at minus 1? So you've got no business drawing a little curve that's too short. Got no business doing that. It was a freehand. Too many of you did a freehand sloppy diagram. Yeah, you get nothing for that. It's got a peak on 1 and it's got a trough at minus 1. So instead of starting off at 1, the reflection of 1 in the x-axis is minus 1. So start there. The reflection of minus 1 is plus 1. The reflection of plus 1 is minus 1. Make it look right. It's not a crude sketch. It's not art, although it's very arty. It's a reflection in the x-axis, so reflect it as accurately as you can. Now what are we doing? Yeah, once again, a very clearly drawn function for you. That's clearly y equals sine x, because they even told us it's sine x, and I've labelled it as such. And if I want to go y equals minus sine x, it's minus the function. In other words, a reflection in the x-axis. So if this is peaking at 1, you've got no business being short of minus 1. If this has a trough or a minimum value at minus 1, this should have a maximum value of plus 1. Okay, it's got to be as accurate as you can. Get, what's this? Yeah, this was really well done by a lot of you. That's the original. I've extended my graph. They want me to go sine x plus 2. So 0 plus 2 becomes like 2. And 91 becomes 90 plus 1 plus 2 more on top, 3. So again, I plotted 5 points there just to make sure I sort of had it all in line. And then ignored this and did my own sketch. Done. And I've got 2-3 marks for that, depending on how generous they want to be. It's a translation using vector 0, 2. You take the ordinary sine wave and lift it up 2 units and draw it carefully. Without points, of course you're not going to get the curvature right at all. You're not, because you've got the idea of the shape. Unless those points are in place, you've got nothing to aim for. You're just trying to simulate the bottom graph, and you'll be very inaccurate. Next one, nearly done, I feel. So the original one is that black one there, and we're given that y equals f of x, and they want f of x minus 1, or f of x minus 1 in bracket, which means you go right 1 unit. So it's quite easy if you do it on top of the original. Minus 2 becomes minus 1, just shift it all to the right. Minus 1 becomes 1, 0 becomes 1, 2 becomes 3. Just make it look right and get your 2 marks. Translation using vector 1, 0. Yeah, I wanted to paste the original one there as well, and then just do a little comparison. Clearly, this one has been lifted up a little bit. How much? Probably about a half. I think they're trying to be a half. There's no numbers there. There's no further breaking up of the scale. So I think it's going to be A is going to be a half, and it's f of x plus something, because it's been lifted up that way, not dragged down that way. So I'm going to call that a translation using vector 0, 1/2. Are we done? Feels done. No, we're not. Some of you did this. You did 2 questions on 1 grid, which is all right, because I did say do it on paper, but you never said which is which. Don't expect an examiner to mark it right if you give 2 graphs, 2 little transformations on 1 grid, and not say which is which. He'll say you don't know what it's doing, this kid. So here's the original function. Lovely looking v. It's very easy. And they want me to go f of x plus 2. Okay, 1, 2, 1, 2, 1, 2. Just raise up the v 2 units. Translation using vector 0, 2. Next one. Yeah, I did click next one, yeah? There she is. Yeah, so this time they want me to do y equals f of x minus 2. In other words, people, not left but right. So minus 3 will end up being on minus 1, and 3 will end up being on 5, and 0 will end up being on 2. Slide it over consistently, pick up your ruler, bam, bam, draw it in, grade 8, thank you very much. Anything else? Oh grief, that one, yes. I think I finished because I was happy. And I actually did it. I mean, I actually did it on the graphics tablet here, and took time. So many of you got this wrong, and many of you who communicate with each other, you share your ignorance. Sometimes you share your wisdom, but a lot of the time you also share your ignorance, and there's a lot of ignorance with this one. I think that's the original one, that v like that, yeah? I think so. So I've labelled it, that's the original function of x. And I have got to, first of all, reflect it in the x-axis. So this goes from that position to that position. Have you got it? So if you reflect that in the x, you will get that. And now, how do you go from here to here? You jump up 3 units, not 5. Where do you get 5 from? You went from there to there, like you lifted it 5 units. You did not lift it 5 units. You first reflect it in the x-axis, and then you do a translation using vector 0, 3. There's my first movement, my first transformation. Then I'm going to go bam, 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 0, 3. And I was happy, and I signed it kind of. I've got 3 hairs growing out of my head, a little bit more from my face, but 3 from my head.